All right, topic for this video is going to be composite volume. What we're going to be looking at here is essentially just how to find volume of composite solids. If you don't remember what composite solids are solids made up of more than one type of solid. In order to calculate the volume of a composite solid, one needs to identify the individual solids that it is made of. So, looking at example 1 here, we're going to try to find the volume of this composite solid. Looks like we've got two different types of solids here. Looks like we have a cone, and looks like we have a cylinder. So I'm going to kind of divide up my workspace for those two. Let's start up with the cone. The volume formula for a cone is 1/3 big BH. The big B is the area of the base. It's the area of this circle down here. Let's go ahead and take care of that part while we're at it. To find the area of a circle, to find our big B, we're going to need to do pi r squared. Our pi r squared here is pi times, looks like it should be 9 squared, since the radius there would be half of that 18. So let me type that into my calculator and see what we get, and then we'll move on to the next part. Pi times 9 squared. I'm getting 254.5. 254.5. I'm going to round to the nearest tenth anytime that I need to round here. Now our H, the height, does not seem to be anywhere. We do not have it. The height of a cone should be the distance going straight up from the center of the circle to the tip of the vertex. We don't happen to have that. However, what we do have is the slant height. And we've got some knowledge that that the height and the radius and the slant height make a right triangle. So what I'm going to do here, I'm going to do a little Pythagorean theorem. 9 squared plus h squared equals 15 squared. That's 81 plus h squared equals 225. Subtracting the 81 gives me 144. And look at that, the square root of 144 is 12. That is a 345 Pythagorean triple, all multiplied by 3. Now we've got our area of the base, we've got our height. Let's get the volume. 1/3 big B H. Let me type that in, see what we get. 1/3 times 254.5 times 12. I'm getting 1018. All right, cylinder time. Cylinder formula is just big BH. Our big B should be the same as we had before because the base of the cylinder was the same as the base of the cone. So that's pi times 9 squared, which was 254.5. Our H for the cylinder should be this 12 over here, which coincidentally was the same as the height of the cone. So let's just do 254.5 times 12. And I'm getting 3,054. After all that, we will take the 3,054, we will add it to the 1,018 that we had. And we will get 4,072 centimeters cubed. And there we go. So we found the individual volumes and we added them up, and that's how you're going to do some composite. Let's head on into the inside here where we've got what looks like 2 prisms. Let's handle the triangular prism, and then we'll find the rectangular prism. Both prisms have the same formula, big BH, but they are going to have different bases. So for the triangular prism, for our big B, we're going to need to find the area of the triangle times the height. So what do we want to do here? Well, for the triangular prism, for the area of the base, it is this triangle here. It looks like it's a right triangle. So we'll do 1/2 base times height. So looks like the height is 3 from the other side of the rectangular prism we can see. And then 13 minus 9 gives me 4 for this part. So I'm going to do 1/2 times base times height, 1/2 times 4 times 3, which is 6. The height of the triangular prism, the distance from triangle to triangle, is 4. So we'll just do 6 times 4, and we'll get 24 for the volume of the triangular prism. Now for the rectangular prism, we need to do big BH, but for that one, our big B should be the area of this rectangle down here times the height, which will be the 3's. So for the area of the base, for the area of the rectangle, I'm going to do 9 times 4, because we know that's 9, and we know that this part here is 4, so we can see it over here. So that's 36, and the height, like we said, was 3. So 36 times 3, let's see about that. That is 108. So we will do 24 plus 108. We'll get 132 centimeters cubed. Okay. What's next? Looks like we got a pyramid and a prism. Volume formula for pyramid is 1/3 big BH. Our big B will do the area of the rectangle here. That should be 8 times 4, which is 32. All right, we can see the 8 and the 4 from the prism down there. That should be the same. And then the height of the pyramid is the 5, right there. So we will do 1/3 times 32 times 5. I'm getting 58.3. Once again, just rounding to the nearest tenth if I have to. And then for the rectangular prism, we have the same rectangle base, but the height of this should be the 2. So our big B, still 8 times 4, which is 32. Our height is 2. So we'll do 32 times 2 to get 64. And then we'll do 58.3 plus 64. And we'll get 117.3. And that should be that. That's centimeters cubed. Okay. Oh, I'm so sorry. something was bugging me. It wasn't 58.3, it was 53.3. Yes, now that makes sense to me. Staring at that 117.3 and it didn't make sense. Okay, so 53.3, sorry. So the 117.3 is the correct answer. I just couldn't read my calculator. All right, so that all lines up now. So let's check out these last two ones. So these ones are ones with, instead of stacking shapes on top of each other, it's a shape inside of a shape. Now, if you ever see a diagram like that, it's representing that that inner shape has been kind of removed or cut out from the bigger one. So what we have here is a triangular prism. So let me write that down. We've got a triangular prism, and we got a cylinder. Now with these ones, we're going to end up subtracting these ones since we're removing it as opposed to adding it on top of. Now a prism is still big BH. Big B is the area of the base. So that'd be like the area of this triangle down here. Area of a triangle is 1/2 base times height. And we've just got a 20 as a side. Now, one thing that you hopefully remember is that if it's a regular triangular prism, that means that it is an equilateral triangle, which means that if we draw in the height, it is going to split that bottom part in half, right? So that part's 10. And if it's a regular triangle, that means that it does have 60-degree angles. So it makes this 30, 60, 90 triangle when you drop down the height, drop down the altitude, right? This would be our 30 degrees because it's getting split in half up there. And then if we want to find the height, we can just do some 30, 60, 90 triangle stuff here, right? That short leg is 10, and to find the long leg, you just take the short leg times √3. And so the height of our triangle is 10 √3. So that means the entire base of our triangle is still the 20, but the height is 10 √3. So that means that the area of the base becomes 100 √3. The height of our triangular prism, we've seen this since from the very beginning there, is 8. So I just need to do 100 √3 times 8, and I will get my volume. As 1,385.6. Our cylinder also has a formula of big BH. It's just that its big B needs to be the area of the circle times the height. Now to find the area of a circle, we don't need to do 1/2 base times height. We need to do pi r squared. Our radius should be 3 since they gave us the diameter. So pi times 3 squared is 28.3. The height is still 8. So we'll do 28.3 times 8. And get 226.4. Now we'll take the two volumes and subtract them. Because once again, that represents the fact that we are removing it from the triangular prism. So subtracting 1,385.6 minus 226.4, I'm getting 1,159.2 centimeters cubed. Okay. So last one here. Looks like we got a rectangular prism and a pyramid. Same idea on this one. We have removed that pyramid from the prism. So a pyramid's formula is 1/3 big BH. The big B kind of represents the area of the base up here. So what is that? That looks like it's a 10 and an 8. So 10 times 8 is 80. The height of the pyramid, they don't have it drawn in right there, but right, that should be the same as this 6 over here. So we don't need to worry about that. So we'll just do 1/3 times 80 times 6, which is 160. And then for the prism, we'll do just regular big BH. The area of the base down here is the same as the area the base was up there. So we don't have to do anything different for that one. We'll just do 10 times 8, which is 80. The height is actually the exact same as well. It's also the 6. So this one will just be 80 times, not 80 times 8, but 80 times 6, which is 480. And then we'll subtract them. 480 minus 160 gives us 320 centimeters cubed. All right, hopefully that went well for y'all. And for the your turn side, you've got 2 to try out. Make sure you read carefully on the second one and give those a shot, and then come back when you're ready to see how you did. All right, so I'm going to start off with the small prism up top. I'm just going to do big BH. Big B, I would do 6 times 10, which is 60. The height is 4, so we'll do 60 times 4 to get 240. For the large one, we'll also do big BH. Big B on this one would be 12 times 10, which is 120. The height is 8, so I'll do 120 times 8, which is 960. We'll do 240 plus 960. And we will get 1,200 centimeters cubed. For our last one here, I'll go ahead and find this cone first. Cone formula is 1/3 big BH. Big B is the area of the circle. We'll do pi times 6 squared for that. Getting 113.1. The height of the cone, we don't really know, do we? It says that the slant height is 10. So this part's 10. This would be 6. So the height, let's do the Pythagorean theorem here. 6 squared plus x squared equals 10 squared. 36 plus x squared equals 100. X squared equals 64. Square root of that is 8. So the height is 8. So we'll do 1/3 times 113.1 times 8. And I'm getting 301.6. For the cylinder, we just do big BH. But it's the same stuff. Big B is still 113.1. H is still 8. So 113.1 times 8 is 904.8. And then we just got to subtract those. So 904.8 minus 301.6. It's going to give me 603.2 centimeters cubed. So hopefully that went well for y'all, and that's going to wrap this video up.